Good evening, everyone. Really happy to have all of you here tonight with us, both physically here and online. So we're really happy to introduce to you the the seventh episode of Powered by AI. We launched the series a year ago, and today we're really happy to have an amazing panel with us that Eve, who's co-hosting the session, is going to introduce shortly. Today we wanted to bring together a number of researchers to discuss the role of AI in the energy transition and how things will look like by 2030. So within NG, we think a lot about technology and how technology can support us in the energy transition. We've got operational objectives, which are midterm, so within the next 3 to 5 years. And we try to imagine the future of AI in that time frame, and we try to imagine how AI will support our activities. So it's really useful to have a different set of perspectives, both coming from the technical sector, so researchers in AI, but also looking at sociology, looking at economics, looking at communication infrastructure, so various perspectives to help enlighten the discussion. So we'll have a session that's an hour and a half approximately, and we'll leave time for questions. And for those of us who are here physically, we'll get time to mingle and to meet with the panelists after the session.
Hello. Yeah, thank you, Mihir. So we are very lucky to have distinguished panelists today with us. I will start with Professor Elena Cabrillo from University of Côte d'Azur in Nice, also affiliated with INRIA, the research center. We have Casey Faust from the US, from University of Texas, a civil engineer by training and assistant professor in Austin. We have Brice Laurent from École des Mines, senior researcher at the Center of Sociology of Innovation. And we have Dario Rodiguero from the Netherlands, assistant professor at University of Groningen, and also affiliated with Harvard in the US.
Thanks, Eve. Thank you very much for being here. Some of you, I know, come from far, so thanks really to help us lead this discussion here today. So we'll start about AI and the energy transition, and I'm looking at you, Elena. I'd really ask you about how you think AI is going to support decision-making systems in the energy sector, in the industrial sector in the coming years.
Okay, so can you hear me? Yes. So thanks a lot. Thanks a lot for inviting me to be part of the panel. So concerning how natural language processing and artificial intelligence in general could help with these technologies, we can think about applying a new branch of natural language processes that is concerned with the fact of making computers and machine understand and generate language through argument mining. So argument mining is a subfield that aims at producing technology to support exchange of opinions, support debate interaction, and be able to extract automatically graphs from the opinion of people. So the idea in this case could be, for instance, to have some debates among people concerning, I don't know, renewable energies or other topics related to energy. And we can imagine to have platforms like, for instance, just to name one, the BCOS platform that was developed by the Open University in London, in which people can actually express their own opinion if, for instance, they agree with a certain topic or stance, or they disagree. And then having technology that automatically is able to detect the different claims put forward by the people and the different evidences. So it means the facts that people try to use in order to defend their own opinion. So automatically we are able to extract arguments from people in a structured way, so that then we can understand if people support or attack each other's opinion. And the fact is that technology allows us to scale. So plenty of people can put forward different opinion, and we are able somehow to summarize in forms of graph all the different opinions and understand which are, for instance, all the arguments that are put forward in support of a specific opinion, attacking it, etc., etc. So that will allow us actually to, to draw insights from these debates and to be able to create structured knowledge from which we can actually extract.
So it's interesting because when we talk about energy and AI, we usually talk about assets. We talk about production. So this morning we saw the hyper control center of energy in the renewable space. But what you're talking about is people, is how we deal with people, stakeholders, people who are impacted by AI, both by energy, who need new energy systems around them, and how AI can support that. In terms of the technology, if we dig a little deeper into the different types of AI out there, so you work on natural language processing, you work on generative AI, LLMs. There's also a huge body of work around traditional machine learning, and a lot of the data that we have in the industrial sector comes from time series. How do you see the hybridation of both approaches in terms of dealing with unstructured data coming from textual input, for instance, with more structured data coming from equipment?
That's an interesting question. I think that, well, different kind of technology can actually be used to reach the goal, because of course all that is information extraction related, let's say classical even machine learning or other kind of even more pattern-based methods can actually be used to check and to find in the data the different either pieces of information that we need or really the opinions, and then we can structure those, because actually we are able to infer and to do reasoning only on structured data. So we need to put together all different kind of other methods to extract from unstructured data, meaning like a discussion among people or coming from other kind of devices, and then to be able to create something that is more structured on which we can do reasoning. So yes, we can actually, depending on the task, we can select the different technologies. Can be symbolic methods, more statistical ones, or more generative. If we actually, for instance, want to provide explanations to people, drawing on their own other bunch of information.
So Casey, you were talking earlier about how you analyze community data. So coming from, for example, narratives, stories, things that are quite qualitative, unstructured. You were also talking about some sort of digital twins of territories and infrastructure in places. How do you think about the combination of both in terms of making those communities more resilient in how things are evolving around them?
Yeah. Hello? Is this on? Okay. First, before answering that question, I think it's important to acknowledge that one of the things that these advances really allow us to do is allow us to synthesize a lot more data from different sources faster, is at the core of it, right? It takes a lot of unstructured data, a lot of conversations, and makes it in an accessible format that we couldn't really do before in a scalable way. So that's the very first thing. And so now, more recently, we are, with things like natural language processing, we are able to do and work through a lot more data from various modalities, various people, and get that into a format that we can actually bring into our models. And that is only going to make our systems more resilient, more sustainable. It's going to increase it's going to allow us to make our stakeholders active participants in our infrastructure systems by able to see their priorities, their concerns, able to see how they use them. And by bridging and actually linking this more conversational people data, whatever format that is, with a lot of our engineering systems, our ground truth data, we're actually able to get some more insights into the impacts it has on communities, how people use it, the decisions that's being made, everything that's more external, but even from internally, our workforce, our challenges, how we communicate to the people actually operating them as well. So I think there's quite a few opportunities there.
All right, maybe Elena, do you have specific examples of your work that you can illustrate?
Well, yes, we are currently working on a European project that is called Orvis in the framework of deliberative democracy. So here the idea is that we have different pilot studies all around Europe, and then we have different topics on which people can actually debate. In general, it's for some new laws or referendum, depending on the specific countries. So the idea is that there is an issue, and all the people are gathered together to say their opinion about it. So we have several case studies in different European countries in the context of this project, and the idea is actually to be able to have this structured information so that we can also put together information coming from different discussion, different debates, different countries. It can also be multilingual, actually. So that is kind of a powerful mean to deal with all these debates and trying to understand also what people think about it, which kind of opinions are emerging, and if there is something that is just left unexplored or unquestioned. So we can say, yes, but about this specific fact that has been put forward by all these people, what can we do with that, etc.
Maybe just a reaction about that, because I think this project is extremely interesting, but I'm also wondering about the the other way around. I mean, would it be possible to use those debates and those deliberations to think about how to use the technology, or even how to design the technology? Because I'm imagining a situation in which we have participants in all those groups and they're discussing, and there is a device powered by AI in one way or another that synthesizes what has been discussed, right? That produces, for instance, a map of various opinions. And then you can imagine a situation in which you go back to the people and present them the map, and they say, "But that looks like nothing that I actually care about, that I am actually concerned about." So I was wondering how to use these interactions with people in the most productive way, which would mean also perhaps informing the technical specifications of the device from what's happening in those discussions.
Yes, we are indeed in this precise moment of the project in this situation, because we have all these pilots that are running in different situations made by sociologists and people in the political area. And we have delivered a first demo that is a bit of like a standard one, let's say, trying to use all the different kind of request specificity from the different pilots, but then it's a sort of a standard one. And now they are testing in the specific use case scenarios, and hopefully, like in a few months, they will come back to us exactly with what you just said. So I'm trying to say, okay, but in my scenario, this doesn't really work, or you should maybe visualize some specific other aspects of it, or I don't know, highlight some specific other part. But yes, indeed, it's actually so. At first, we collect other specificity to have like a sort of a fit them all demo, but now we are back and trying to gather all the different feedback from the different pilot studies. Yes, we are there.
Yeah, it's interesting to me how we keep on coming back to the public debates and people around, how to influence people and how their point of view influences projects. So AI for a long time and up to now has gone through various phases around helping raise awareness in communities. We were talking about that, how we can get more information out there, out there to people. It also helps in analysis, in support to decision making. And now we're seeing that it also can be used for influence, positive influence, hopefully in many cases. And in terms of the human-machine interactions, we're moving to potentially machines making decisions with human supervision rather than the opposite. How do you see in those cases the AI technology evolving to support that? And what's the role of the human and institutions in enabling trust, for example, around those topics?
No, I was about to start maybe with more general reflection, starting from your question, because I mean, and even in the title of the session today, the future trends, right? It's almost as if we could foresee what AI would be in the future, as if AI was happening no matter what, right? And would happening without anyone making any choices. And we know it's not the case, right? We know that there are companies making choices, governments making choices. We know that these choices are about the technical priorities. We know also that these choices are also about what is AI for, right? And there might be an interesting situation in which we make choices, but we don't even realize that we have to make them. And this is particularly the case when we think about the objectives, the what for, the purpose of AI development. So it was very interesting in a report that was published about a month ago by a British think tank called the Institute of Public Policy Research. And they did quite a big survey of British companies. Maybe they sent questionnaires to 3,000 of them, asking them the ways in which they used AI and why they used AI. And they realized that the large majorities of the surveyed firms were actually using AI, but most of those companies didn't know why they were using AI. I mean, we were still wondering why we know somehow that we need to use AI, but we have no idea why AI would be good for us. We're still we're still looking for the higher purpose, so to speak. We're still looking for broader direction, and this is something that is extremely important to keep in mind, because if we want to benefit from AI, then we have to think about AI for something. And when we think of AI for something, then it's not just a matter of having this technology that is out there that we need to keep up with and that we need to use, but the interesting question becomes, what is our problem? What do we want? What do we need technology for? And then finding ways to use the technology and in some ways that are as relevant as possible. And then we can get to what you're saying here, not just AI that would solve everything for everything at once, but AI is just a component of something that is more complicated, that also have humans in the picture, and most importantly, perhaps, AI as a component of something that addresses a real-world concern, a real-world problem, and is particularly important for energy.
Yeah, and this is a perfect segue to our second section that is actually about infrastructure and societal impacts, preparing for 2030. So there is a lot of work being done, of course, on the infrastructure from the technology point of view. So building the infrastructure, leveraging any kind of connectivity, AI, etc., to enhance the efficiency of the infrastructure. But now we're seeing, Casey, that AI has a role in the infrastructure planning and management, but as your work has demonstrated, that can also be leveraged to actually analyze the impact on the communities, the impact on the workers, so not only the infrastructure for the people, but the infrastructure by the people building it. So would you like to maybe elaborate a little bit on this and illustrating that with a couple of your projects?
Yes, absolutely. So when we look at infrastructure planning and management broadly, there's some really obvious applications for AI that I think people are leaning into, such as document management, streamlining those processes. But one of the most powerful ones that I'm finding is having it be a bridge between the engineering and the communities with which the engineering is operating in. It is a way to allow us to have adaptable communication, for us to be able to extract data from communities in an interactive and usable way, and make them a part of the process. And whether that is something at a community scale that I'm doing in Alaska, where we're actually looking at villages and what do a lot of these villages need to be relocated. They've been identified as at risk from climate change. And we're looking at, okay, in the meantime, during this process, what are the assets that we protect? What are the ones that we relocate? And what are the ones that we retreat? So we just move back a little bit. And actually being able to engage with the community in an interactive way to converge on that planning and reach agreement on, with unlimited funds and resources, where do we put those? And it allows us also to engage with stakeholders that maybe we haven't always engaged with, a lot of our hidden stakeholders that haven't had a way to, or the power to actually have a voice. by bringing them into the conversation through different modalities and means in a way that's accessible for them. So we can have adaptable communication. And then it also allows us the opportunity to take that information back to the unstructured information, the conversations, the dialogues, and actually do something with that to feed that back into the process, whether that is something about how, which resources are going where. Some of the project planning for execution, it can be which ones are the most urgent and why. Looking at different solution sets and creative solutions. So there's a lot of opportunity here to, I would say, almost use AI as a lexicon bridge between people of different education and knowledge structures on the ground to really bring those lived experience and narratives into the project planning process. There are also other ways that we can use that back to like the communication is oftentimes when we're looking at from the operation perspectives, we're really, really depending on people to be active participants to maintain our system functionality. Our systems, whether it is energy, whether it is water, they are meant to operate in a certain way. And when it's starting to be pushed out of design tolerance, oftentimes we need people to bring them back into design tolerance. They say, don't use so much energy, stop using water, please conserve water. We have all these different stages where what we're really saying is we're about to push these systems out of design tolerance and we need your cooperation to actually bring them back. And the nice thing about AI is it's giving us an opportunity to really tailor messages to different target audiences, whether it's language, whether it's education, whether it's the different publics, all of these various publics, to try to encourage behavior to help us bring these systems back into design tolerance and streamlining this process of really active participation. I don't know if this has kind of been a theme a lot of us have talked about, so I don't know if some other people want to chime in there.
Hello. Okay. I'm coming here with my experience in data visualization because at a certain point you collect the data, you process data, but how you deliver this to an audience. I'm here just to say that AI is very complex and we make it visible somehow. There is a new research discipline which is called information design, and especially we have very sophisticated tools like network visualization, and this allows us, for example, to collect this kind of information, especially when you have inquiries, when you have interviews, if you want to analyze large amount of text coming, for example, from a community impacted by new infrastructure. So what you can do automatically is using a system of text analysis, like mentioned from Elena, and try to summarize them in visual maps and eventually pass this to the professional. And I think that data visualization is very interesting here because this can represent the kind of a material that can be used to foster a discussion in a community. So to have a material, to share material and see how it's possible to build a dialogue between the actors in new infrastructures.
I think on that, one thing that just reminded me of that is also back to having people be active participants is people are often, whether or not we acknowledge or not, are human sensors in our infrastructure systems. They alert us to a lot of issues, whether it's reporting a pothole or a pipe break or an energy outage. And this is allowing us to streamline a lot of those processes and create visualizations and hotspots and communication of vulnerabilities. I mean, there's equity concerns around that about who actually reports and where you need passive monitoring, but it is another data point that this is allowing us access to in near real time through these to combine these different sources in a way that the utilities can use, for instance, identifying where they need to be sending field crews out for something as simple as that, or concerns that need to be addressed. So I think with the visualization, it is a way to really interact and link with the public.
If I can just react on that, because I think your two interventions really go well together. And I think it's really an interest of AI in thinking about those things, because as you said, it's a way to bring together heterogeneous data. So for instance, quantified data, something that's been measured by inhabitants, for instance. But there would also be almost a democratic problem if we were to think of citizens only as sensors, you know, like, and if we get into a situation in which, oh yeah, it's too difficult and too costly for the state to look at the status of infrastructure, so let's ask the people to do the job and do the measuring themselves, right? This would be extremely problematic. But then it's entirely different if we consider that, citizens can act as sensors, can provide data, but they can also provide concerns, they can also provide questions, they can also provide issues. So things that are qualitative rather than quantitative, that can be not as easy to plug into a given monitoring platform, for instance, but something that can also be associated with quantitative data if we have the right tool. So if we have the right tool for collecting heterogeneous data, and if we have the right device for visualization, and it's here that maybe everything that what you two are talking about can be extremely productive for how we think about life in a given community.
And I think that really is an important point, that this isn't to replace anything, it's to give us more data, more information, more accurate data. But I also think there's a lot of room when you look at the socio-technical space, a way of communicating risk around infrastructure and reliability. And I think that's something really, really important also when we talk about visualization, when we talk about functionality, the resilience of these systems. I think it's a really powerful tool to allow us to bridge between the technical system and the contextual environment that it operates in, because it's allowing us to converge and integrate all of these data sources.
And yeah, maybe before jumping to the third topic, I think that we have a couple of alumni from MIT, and at MIT, especially at Sloan, there is a famous course called Complex Dynamic Systems and the modeling related to it. And actually, Casey, you've shown to us earlier on in another context a very complex dynamic system of the different decisions in these remote communities. And when you think that you have cracked a problem by understanding how the civil engineering topic could be tackled, there are many more other reinforcing and balancing loops that are coming there. And one of them is actually the worker shortage. And the way that the information can be crafted so that they are more successful in how the workers can be applying and selected. Can you share a little bit more on this project, please?
Yeah, and I just want to back up a little bit to what you were saying about it's coming from that same theory. It's actually coming from systems theory, which complex systems typically is falling under. And so one of the first things we do when we do a lot of these problems is we do mapping of the factors and how they are interlinked to whatever the behavior of concern is, usually the functionality of the system. And the worker one that you're alluding to is one of the big threats in a lot of these rural and remote communities that we were working with was the loss of institutional knowledge and absenteeism. So basically, there was a high turnover rate, as well as there's a looming, they call it the silver tsunami in the States. I don't know if that's adopted everywhere, but we have a lot of people about to retire, and we have about, depending on which utility, where you're looking at 30% vacancies in a lot of our roles. So workforce is a huge, huge threat to actually be able to operate the system. And so we're not getting enough skilled applicants to apply and stay there for their careers. And so this is one of the vulnerabilities that we're seeing in a lot of places. And I was talking to a lot of colleagues in the social and behavioral sciences about why this is happening. And they introduced me into an entire body of literature around this type of work, around how you recruit, around behavioral archetypes and getting the right skills here. And through some conversations, because a lot of the work I'm doing is interdisciplinary, we have a lot of people from different disciplines converging on a shared goal. And so we started looking, how can we operationalize this theory on why people select jobs and careers in order to design job ads to attract the right people? And how do we use AI to build models such as LLMs or other that actually tap into this theory through rules and guidances based on the job to select the right behavioral archetypes in order to design job ads in order to increase what we hope is the number of skilled applicants that we get that will stay. And so we're in the process of doing that. We think that it's feasible. Everything says that we can do this, and we will hopefully be testing this sooner than later. But we think that we can tap in this theory and make it accessible for engineers to use in a way to help us design the way we communicate these jobs and the values of these jobs to get the right people and to hopefully start chiseling away at this problem.
Just to to follow up on what you were saying about skills and vacancies. So you're all educators in universities, and I'm curious about how you think about the AI reskilling that's going to happen. The fact that a lot of jobs are going to change. The economic situation is quite harsh at the moment in some industries, both in tech and, like you were saying, in industry, there are vacancies. There's a gap in the types of skill that we need. So if we were to think about in the next 5 years how we reskill our employees, how we educate and train people who are in universities currently to use new tools, to be in roles that will necessitate new ways of working that we haven't invented yet. How do you think about that in your education role?
For example, I'm living and working in the Netherlands, and I would say that the educational system there is pretty resilient, so it's very easy to create new programs. And what we are experimenting right now is not to offer just educational programs related to data science and AI, but we try to connect this with practical examples. So we call this Data Science Society, and it's very different from a School of Engineering. And what we are able to teach to students is not just hard sciences, but also the fact that they need to know information about privacy, about government, about regulation. And in my case, I try even to feed them with dimension of data that is related to the visual form, to data literacy, to how to cope with this data. So something that is interesting is trying to shifting the engineer into the societal issues, and yeah, this is what we are doing.
Would you say that we're moving away from specialization back into more general profiles that are more adaptable with transferable skills?
The students are more holistic at this point. And also what is happening is that despite you are not a specialist in something specific, but you have a broad view on something, instead of focusing on the discipline, you focus on the project. And they have an opportunity to develop specific skills just trying to work on a specific subject. So this is interesting, and I think in the future we have to approach problems in a very diversified way. And this is the response of the educational system, at least in the Netherlands.
I'm going to push back on one. I think I agree on a lot of that, but I think we still are going to need specialists, especially like for civil engineering, for instance. We're still going to have the T model, where we have somebody with expertise, but the top of the T and the skills they need, I think those competencies are going to broaden. Because, for instance, we still need people who can design the connections, right? We still need people who are in construction running it. So there still will be specialists, but I do think that we have to, the requirements for the generalist, the top of our T, is going to be much broader. So, but I don't think it'll get replaced. And this is actually something we're grappling with right now that's coincidentally happening at the same time, is we're actually redoing the curriculum at the University of Texas at Austin for civil engineers, because we recognize that it hasn't been done since the 50s in the States, and the competencies are different. And we recognize we still need what we call those horizontal ones, which is our geotechnical engineers, our structural engineers, our these specifics, but there's a lot more cross-cutting competencies that they need. AI training, they need policy training, just a couple of various ones that we believe that they're going to need as well. And we're actually trying to figure out, how do we teach both, right? How do we teach the infrastructure of the future that has to manage both people and technology now? We have driverless cars and driver cars, right? For instance, how we with electric vehicles. We have to be able to teach students to do all of the above in terms of planning for infrastructure, in terms of their analysis types. But I also would say, and it's not maybe as drastic, some people may agree or disagree, but this isn't the first time we've had a big disruption to education. Like, people have made a lot of these claims, like when the internet came out, that, you know, people weren't going to be able to critically think, that this, how are they going to know which sources were good and what was reliable? So although this is different, we've had a disruption like this before. And I think we will adapt, and I think it's going to allow us as educators to do different things we couldn't do before, as long as we lean into it. And hopefully we figure out how to do that pretty quickly, because it's coming very, very fast, whether or not we want it to or not. So.
If I can jump in, because I totally agree with what you're saying. I mean, it's also, I mean, every 10 or 15 years there is a new technological revolution, and there is a new thing that will revolutionize everything, and everything will change. And of course, part of that is true. I mean, there are new things for sure. But then what is needed is also to train people, particularly people in engineering or general management, to be able to understand how technological innovation works, right? To be able to understand the ways in which technology interacts with society, and to be able not to take all those promises for granted, right? Not to be put in a situation in which they would be in a constant fear of being, you know, or not being able to keep up with technological advances. The people we train, at least that's what we want to do at École des Mines, we have the ambition to train people who would shape technological changes, you know, who won't be in a position that they need to follow them. And to do that, for instance, about AI, we do like small group inquiries about you know, controversies about this or that policy programs. And to do that, we try to connect work on technological advances, but also work on, for instance, environmental costs. And we've been doing a very popular thing that ties classes about AI, but also considerations about data centers and how to do the energy costs for data center, and what does it mean to construct an infrastructure that allows AI to fulfill its promises, hopefully in the future, and so on and so forth. So all this is a way to be able to take the promises of technological revolution with a grain of salt, to be able to shape what the technology development will be, hopefully at the service of broader social goals.
Yeah, and I think that on the reskilling and upskilling aspect, AI offers also a fantastic opportunity to get better at it. So it's not only being or understand fully the technology behind AI. It's useful, but not for everyone. It's a little bit the same as, you know, the time of internet. So did we need to understand how a network switch or even an HTML page was built? You know, those jobs existed and still exist, but the power of internet was definitely how to use that, how to leverage that, how to build new business models, new things on the top of that. And I think that's a little bit similar with AI. So it's never bad to understand how that works, but we know that it's changing quite a lot. You know, from machine or statistical symbolic rule-based, statistical, machine learning, deep learning, generative AI, multi-agent, physical AI now. Well, it's always improving at a speed that probably has been unseen before, but how to really leverage AI in the daily work of most people in organizations in our society. And when I say that AI is a good opportunity, I can refer to actually some of the work that we've done that we called adaptive learning thanks to AI. So basically for workers, could be on for RTE, the TSO here, transmission system operator in France. We are actually helping operators to work as a human agent with a lot of AI agent and orchestrating all the tasks, but really working together. So a part of the tasks, like mundane, routine, are actually offloaded to the AI. And what really needs the human creativity, the human experience, the human maybe intuition, the human reaction is actually, of course, dedicated to the operator without the mental load of all the routine tasks that could consume your time and your brain. And that's the same adaptive learning. That's some of the examples were for the air traffic controllers or the pilots who need to, by regulation, retrain themselves every X month. A part of the curriculum is, let's say it, quite boring, but you need to do it, and some are really good at some tasks, others are different. So if you don't want the people to get bored and really to be super efficient in the way they learn, you need a kind of AI instructor to detect where the professionals who is under training is good at, and then to adapt a new curriculum to that. So I think that's a part of the future. And when internet allowed a new way to be educated by maybe the MOOC, distant remote learning from prestigious universities like probably yours. And but now that's this adaptive learning that might be interesting to be, and that's more personal, a little bit less theoretical. So you're on the job when you're training, which is, I think, quite interesting as well.
One quick final thing to add to that. I think you said something really important that I wanted to tease out, and it's the learning is changing. But I think it's really important to acknowledge that the way people learn and their brain will change as a result of this. So with the internet, for instance, people no longer memorize things; they categorize where to find information, right? So they've had some studies that look like people actually learned differently. So for instance, I remember phone numbers from when I was a child. I don't remember any phone number from college on, not to age myself or not, but we now know where to find information as opposed to memorize information. And that came about because of the internet and the accessibility. I don't know what AI is going to do with adaptive learning and whatnot, but we're already seeing students are learning differently, and we're going to have to change our teaching to meet that.
So maybe to plant a seed, and we'll switch gears in a bit. So we've been talking about how AI as a solution is maybe a solution in search of a problem in some cases. In some cases, in the industrial sector, on the energy sector, where we use AI as a tool, like we use digital, and we optimize our operations. It acts like a lever to operations in terms of production, distribution, helping customers consume better, optimize their energy footprint, carbon footprint, etc. On the other hand, there's the question, and I don't know if you wonder about that, but is AI a tool like any other, like the calculator, like the internet, or is it something that goes beyond when we talk about artificial general intelligence or superintelligence? Is it something that has a much broader impact and that is no longer just a tool, but a way of working? And in those cases, in the industrial sector, for example, there's use cases that will use certain technologies to support the activities, and there will be new ways of working where AI will be embedded in the way we live, we work, and what work means.
Maybe just a short reaction about that. I'm not sure about the word tool, because on some level it works. I mean, we're using AI to do this or that. But then if we think of AI as something that is pretty much in the making, we don't know exactly what AI will be for in the future and what the next technological developments will be. If we consider this, if we consider that AI is not, it cannot make a difference by itself, right? It has to be connected to something else. It has to be connected to other technological systems. It has to be connected to human users or human producers of data, for instance. Second thing, and when you consider that for AI to deliver, you need lots and lots of work, right? You need lots and lots of infrastructure, you need lots and lots of energy, you need lots and lots of data. This is extremely costly. It's already starting to be problematic, so we don't know exactly, whether or not we will be able to meet all these promises in the future. So, well, that makes AI much more than a tool, right? That makes AI something that is completely hybrid, that makes sense only if it is rightly connected to other sectors of industrial or human activities. And that makes AI something that will work only if all those components are taken into account. There would be almost a risk in thinking of AI as a ready-to-use tool that we could put from the shelf.
So that's a great transition to talk about how do we balance innovation with societal values, with the common good. There are some projects that all of you have been working on in terms of democratic engagement, public trust in AI systems, especially as it relates to energy or industrial initiatives, and the regulatory framework. So we're seeing, work that we're doing in Europe that are going quite far. Other geographies, other countries are following in different ways. They have different philosophy about things. Could you share a bit about your work in this regard? And
Yeah, sure. I mean, maybe a little bit about context. I mean, the interest. One of the reasons why your question is interesting is that we live in a situation where there is certainly a crisis of public trust in expertise, right? Where there is the ways in which experts can be trusted is not at all pre-given. I mean, it's extremely challenging to the point that we can even ask ourselves whether the existing institutions of public expertise will still exist in a not too distant future. And in situations such as this, I think it's extremely important to think about the ways in which one can restore public trust, right? The ways in which it's possible to envision a better connections between science and technology and society. Otherwise, we'll keep, putting ourselves in a situation in which experts and other people will say certain things, and then there will be public backlash, and then the dichotomies between what science says and what society says will grow more and more problematic, and we can already sense why this situation is problematic. And to do that, I think it's important to think about the ways in which AI can built on the contribution of people, but also can deliver on people's problem. And I think we already addressed some of this in earlier in the discussion, but it's still something that is extremely important to think about, and certainly regulation has a role to play in that, and it has a role to play, especially in the situation in which for certain actors in AI development, mostly coming from the tech sector, a good role for the regulator is that he or she should do nothing, right? Or even better, that the regulator is here just to create special conditions for innovation to thrive. For instance, regulatory exemptions, etc., etc. And that's why a concept such as the regulatory sandbox, for instance, is extremely popular for certain innovators, particularly in the tech sector. But this is problematic, because if we go too far in that direction, then we leave aside the very possibility to define shared goals. We leave aside the very possibility to create priorities that could be thought of as collective. And here there is an interesting regulatory challenge, meaning that a challenge that would consist not only in making sure that AI innovators can do whatever they want, but making sure that regulation is here to help AI go in directions that are beneficial for the many and not for the few.
Yeah, what you're saying, I think, encompasses a variety of topics that we're interested in. So from trust, it also, we can look into transparency and explainability, like Yves, you were mentioning, the fact that a lot of systems, a lot of technology that we use are black boxes, whether we know about it or not. There's the issue of deep fakes, for example, in one aspect of AI. The fact that it also acts as an influencer, and we've seen through social media, recommendation algorithms shape the way that people think and react to events. There's also the cybersecurity issues. resiliency of networks. A few weeks ago there was this blackout in Spain and Portugal, so the root cause analysis is going on, but there were questions about whether it was a cyber attack or not, which may not be the case, but generally we're, all these different threads come together in terms of thinking about technology and how, if we were to trust it more, to let it replace some of the activities we do, what's the role of humans? And I know that, Dario, you do a lot of work in human-machine collaboration and how we interact with technology. What's your position on this?
I would say that my position is not I wouldn't say important, but it's also true that we can say and we can use that artificial intelligence can be used for leisure or just production of images or something. So now we are talking about infrastructure and many other things impacting society, but I think we can even have a lot of fun with AI, and I think GPT was not mentioned so far, but I mean, this is a way in which AI is coming as a tool to us. Of course, it's a sort of a black box, so we have to understand first how to use it, because now a lot of people it's using it at work, at school, at the university. So, for example, we are debating at the university how we have to change the educational programs to cope with the fact that the students are using GPT and also the professor are using GPT. But I think there is the need for a little bit of lightness and try to see and explore what artificial intelligence is bringing us, even in terms of creativity and use of personal data and personal content.
Yeah, and I think that coming back to you actually, Dario, and the expertise in knowledge, design, and visualization, how one feeds the other in a kind of almost exponential way. So new ways to design the knowledge, feed the visualization, creates new knowledge, etc., etc. Will be interesting to share with the audience a little bit your work in this field, and I think we have one picture in this slide, and that's a little wink to the MIT community again, because you've done some mapping AI from the MIT Tech Review.
Yeah, sure. And maybe it's valuable even to mention that I spent 1 year and a half at the MIT, so I'm very proud of this institution. And I would say that the MIT Technology Review is a very nice, let's say, magazine to be updated. And, sometimes we are playing a little bit with this. So the question for this kind of a visualization, because I'm visualizing data, is to say, what is artificial intelligence, starting from magazine articles about artificial intelligence. So what we were doing here is to analyzing a large number of articles of the last 5 years into the magazine. And we are taking a little bit the visual grammar of weather maps in this visual. So basically, we try to put together the articles by text similarity. So we create a cluster. So in a way, it's like a metaphor to organize a library, a personal library. And with artificial intelligence, we can measure the lexical distance between the articles, and then we can cluster them. And by clustering them, we can organize them. And also with artificial intelligence and machine learning, we can even identify the cluster. And something I'm doing lately, which is very fun to me, is also ask GPT to create labels for me. So I said, listen, this cluster is containing, 20 articles, what they are talking about. And before it was impossible to do this, or it was possible to do something by using the frequency of the words in the text and more statistical methods. But in this way, you can kind of establish a dialogue. And you know, we are doing this in Python, JavaScript, so GPT can be can be used with APIs. So we can just give some information and saying, asking just give me a label for this cluster. And in this specific visualization, we can see in blue some trends that are disappearing from the public debate of the magazine, and in red we have the new ones. So you can see even how the let's say the debate of AI is taken in this specific magazine, the MIT Technology Review.
And you've done some work as well on the energy sector, looking at stakeholders and how to analyze using visualizations the positions of stakeholders, for example, in terms of infrastructure projects in the energy sector. Can you describe a bit that work?
Yes, even that one was interesting. We were working with the Media Cloud, which is an initiative from the Berkman Klein Center, and basically they are creating an archive of newspaper articles. Today they are archiving all the articles in the Internet Archive, because there is some legal issues in publishing the full article of the magazine, but they found this way to release this to the public. So for me was interesting, and what I can do actually is to transform my query, answering all the articles related to renewable energy of the last 10 years, and I can get back, I don't know, millions of articles. And doing this kind of visualization, I can summarize a very large span of time and the text in one single image, which is fascinating to me.
And we know that you know, large infrastructure like the energy systems are very multidisciplinary and interdisciplinary. Plus, there is a static view of that and a dynamic view of that. So it actually brings some challenges when we want to visualize that kind of data, especially in a collaborative way. So I don't know if your research has been carried out on such topics. The dynamics, we've seen that on two, let's say, static aspect, but what are the trends currently, and how those trends in the visualization could maybe be leveraged by an organization like ENGIE?
Yeah, I mean, basically now we are witnessing a change of paradigm, at least for network visualization. So we are moving from a kind of a technology which is called force network diagram to something that is more related to machine learning and embeddings. And especially when we are talking about text, we can really use embedding to do visualization in a very short and quick way. But again, the question is to have proper data, because without good enough data, if, for example, a newspaper articles are not available to the public, it's impossible to create this data visualization, and also to present how the landscape of renewable energy, for example, changed over the last 10 years. So it's important for me, even the question how I collect the data and if the data are available or not.
And I mean, of course, the data are important. And as I've mentioned before, if we manage to offload a part of the work of the human on for the mundane and routine activities, it leaves more time to bringing some creativity, some new ideas in order to maybe solve a problem together with the machines. So in that aspect, the human-machine collaboration that we've touched upon earlier on is extremely important. And we've seen earlier on, as Mihir was mentioning, the Hypervision Center of ENGIE. that is quite remarkable. It offers an overview of all the renewable assets in the world with some dynamic display, etc. That's fantastic, and at the same time, I think that all of us have identified some ways to inject AI in this tool, and it comes from the visualization, from the common knowledge or collaborative knowledge that would be brought of. I mean, what it inspired to you? Do you have any starting from the visualization and maybe to all of the panelists, this hypervision controlling overviews, how can we inject maybe a kind of feedback loop in the system? Today, that's the kind of push, what exists from the asset to for visualization, but then we can, of course, inject also some human knowledge there and getting better overall.
So to enter the conversation. Yeah, no, I mean, this morning was very nice because we visited this new monitoring center, and from there you have 4 big screens with a big visualization, and you have a map of the world, and it's quite astonishing to think that you can see in real time the production of renewable energy from all over the world. South America, Europe, Asia, and everything. And I think this is showing the potential of data visualization, of course, because if you think that we are all connected with these different sides of production of energy, it's just beautiful to see this kind of world cartography of the world and see how it's changing in real time. And yeah.
Maybe a reaction about that, because so I don't have an answer to your question, but I just wanted to say something about energy and renewable energy particularly, because we all know that the situation about renewable energy is particularly difficult today, and that the political debate about why it's important to transition toward other sources of energy is not, I mean, it's way more problematic now, and it's not self-evident now for a large spectrum of the, a large part of the political spectrum. And I think this situation says something of perhaps an ability to turn renewable energy and energy into a meaningful topic for political debate. And maybe it's at some point that visualization can help. But as you say, it would require thinking about visualization as something more like a platform for collective discussion rather than something that says, this is reality and just shut up, right? But more like, here is where, as a society, where we would want to go, and we have to discuss what are the best ways to go there.
Yeah, no, absolutely. And I think that this feedback, Casey, you had one case of a digital twin where, I mean, that's a palpable even digital twin that you're creating, and you're in the process of bringing some feedback as well in that display.
Yeah, so one of the things that a lot of the work I'm doing is trying to bridge the engineering with the context in the communities and or workforce. And so it's important for us to be looking at who needs the information that's being generated from that thing and who is interacting with it. And a lot of times those are very different. So in my case, we need engineers and planners to receive the information in a usable manner that is generated from whatever the interaction is. And the interaction itself is going to be in this case of the one we're working on developing right now will be the community interacting with the digital twin or the digital rendering. And we need it to be in a format that is generating the information and the feedback we want for a start. And so it's got to be usable for that interface. And when we talk about, and that's something that's been coming up a lot today, is how do we develop at a very high level, how do we develop the tools and who should be involved in the process? And we've talked a lot about like the mission, what's it for? And I think when we're talking a lot about these visualizations, one of the things I asked while we were there is, what is your role? Like what is the job here? Like this is really cool, I love this visualization, but so what, right? And so it's one thing that I always come back with in the engineering is that so what? and a lot of that was, the risks to the asset and asset management. And when we were talking about different layers there, it was things, some of the conversation came around like sociopolitical risk. And I think AI, for instance, is going to let us bring in these different risks for visualization and rethink the way that is and way that information is received. For the digital twin, for instance, when we look at that interaction, the goal for that is really going to be around how do we generate that knowledge from and this unstructured information to get it back to the engineers in a different format that they can use. And I feel like that's a lot of the goal from the hypervision, not necessarily unstructured information, and for the very disparate, disaggregated information into a usable space. And I don't know if that really, I kind of went on a tangent there, so.
So one way, and I think about the future of AI and energy. So there are maybe two pillars that I think about, and maybe you can react to them before we open up to the audience for questions. One of them is around data and the data transformation and what you called knowledge design, and the fact that we need to manage knowledge as well. And graphs, for example, as a representation for semantic knowledge, for instance. And that is sort of the raw material that we need to power AI models and agents, etc. So that's on one hand. And on the other hand, the fact that we talked about digital twins, not just of physical infrastructure, but also we can talk about digital twins of people, of digital twins of processes, and AI can support and replace some activities that are the lower hanging fruit in some cases, and rethink the whole organization of a company based on the digitization or AIification of these elements. I don't know if you want to react to these two layers, which seem to be one way of synthesizing the direction we go in terms of how AI is supporting the energy transition and generally the corporate world and industrial sector.
I can spend a couple of words about this definition of knowledge design, because basically what we think about knowledge can be books, can be libraries, of course, with the data and this intangible knowledge. We are thinking in a different way how to create the final devices to deliver this. Just think about the books, how they change in the last 20 years. You have digital books, you have a PDF, you can use your laptop to read newspapers. So the same question can be shifted, of course, on the energy, and for example, even this idea to have a monitoring system that is able to collect all this knowledge, which is part of the system itself, but it's defining somehow how we are going to deliver the data, or just we have the fact that we have private rooms in which we have screens in which we are showing data in real time. It's giving you a little bit the idea how the shift of knowledge design is changing. So it's interesting to think in a very abstract way, because we are a really new material to think about, to share, and give a form even in terms of design.
What maybe I can add, sorry, about data, is that what is, so when we talk about AI as like generative models, we know that they are trained on a lot of data of whichever kind and from whichever source. And what is very important, I think, and it's something that we should really care about from now on, is to have like trustable data. Because when we start to use these LLMs for serious things and not just leisure, as you were saying before, we need to trust those data. We need to know where they come from. We need to have the possibility to inject specific data for specific tasks, as for instance is done in like instruction tuning or in like RAG, this retrieved argument generation, in which beside all the data that are learned by training for like general purpose, we can inject specific data that are clean, that are controlled, and then can fit to the context that we are targeting. So I think that is very important. Not, of course, we need general purpose data to make those models work, but then we need also to be able to find ways to control what is there. and so that we can actually trust those systems. Because as what we were saying before, I think what is really important to keep on teaching and to even in educational programs, etc., is to have critical thinking. So it's not just to take what these systems propose and to fully trust it, but okay, let's check it. Let's try to be, let's use it as, if we don't want to use the word tool, but like something, some support, but then we keep on having this control over what I produce. That's, I think it's pretty important.
And what's interesting to me is that the human in the loop aspect, whether it's in developing new models or being subject to models and their output, is always very present. So when you're developing new models, it's either reinforcement learning with human feedback, so at the very early stages, or if you don't do that as much, it's evaluating the output of a model because there's more hallucinations, for instance. So there's always human participation in the trust process that we need to take into account. So maybe let's open up the question to the audience, those who are here physically.
Excellent discussion and great group of experts, Amir and Yves. It's really a pleasure to be here. You guys covered a lot of ground, so it was just something was really on my mind this week was the Anthropic new release and their kind of tests that they ran. And a few times you mentioned things that made me think about that. And I guess the Claude Floor is out. I haven't really made a heavy use of it yet, but the system card suggests that it's a little bit dangerous. They mentioned that it blackmails people that try to shut it down and tries to reveal like extramarital affairs if it's given access to email, kind of disturbing stuff. And they apparently dialed it back, but not completely. I don't know. You know, that I thought Anthropic was the safe one, you know, and so why are they releasing this kind of a model? Anyway, that's one set of issues. You mentioned hallucination, broader set of risks. They also mentioned AGI being, even if we don't get there within 5 years, all analytical work could still be done by current models within 5 years, and maybe within a year. I know economists are talking about 1 or 2 years, leading AI economists. Anyway, that's pretty profound. I don't know whether, you know, how do you think that fits in all spaces? Is that just like a narrow slice of work? I mean, last year people were talking about 4% adoption rates. I heard today 40% adoption rates now. I don't know if that's real or not, but anyways, like the curve is like GPT, general purpose technology, like that we've never seen before. Anyway, I'll stop talking.
I know, Brice, you were talking about the promise economy. Maybe you can elaborate on that.
Yes, exactly. We were talking earlier this afternoon about the economies of promises that goes with AI. I mean, it's built in, right? Every actor in AI has a very built-in interest in promising a lot, right? And it's a way, because it's an economy that works entirely on investment. It's the idea that there will be immense amount of revenue in the future, and that it's okay to spend a lot in the present, right? And to maintain this situation, you need to bet on the future, basically. And this is, I think, it's important to recognize the situation, recognize that there are indeed new things and important new things happening, but also trying maybe to diversify the perspectives. And I was in an earlier conversation, I was mentioning a recent article. It's a scientific paper, and it's interesting because it's I don't remember the exact title, but it's along the line of stop trading AGI as the North Star direction of AI research. And the argument is very good because they're saying the authors are practitioners of the field, and they're saying that by considering that AGI is the direction, then we tend to downplay scientific diversity. We tend to downplay the technical and epistemic challenges in actually producing meaningful innovation. We need to sideline the risks, such as the one you were mentioning. So the people who wrote that paper, which I think is very good, argue for being much more open to what AI can do, right? Saying that, well, it's probably not, it won't probably replace the human race, and that's probably a good thing. But we can think of various things and various ways in which AI can be associated with existing technologies.
Another question?
Thank you for the conversation. And especially as a behavioral scientist, it was really interesting to hear decision making as being really important. And it was mentioned what for AI is used, LLMs. And in the current discussion, it seems that all these conversations about existential risks and what these models are capable of are shaped by big companies. And so it was mentioned like because of investments, and also there is media incentive because we need this kind of, the media has own biases in order to create like these headings. And I'm curious, it was mentioned that there are some initiatives happening, and are you working with general public? Because I feel like they're quite vulnerable when it comes to understanding what is really happening, because from one side, LLM models are overestimated to some extent, but also underestimated when it comes to risks that they, what kind of risks they expose to individuals. And also, I'm curious whether you were able to see any kind of interesting biases when it comes to analyzing media, all these articles. Is there any kind of exaggeration of these risks? Is this narrative shaped by certain actors? So it would be really curious to hear. Thank you.
So, for example, when we were doing this map, this is just one section of the map. But for example, when we run this analysis, we're pretty surprised about the role of China in AI, and it was taking a good part of the map, I would say, in the last 5 years. So more recent debate, but more elder debates. And for example, when, I mean, it's interesting because, yes, we are talking about this, but then with this kind of a map, you can analyze if your model, your visual model is consistent. So you have, let's say, to interpret the map, and the interpretation is up to the humans. And for example, we have noticed that most of the conversation in that area were related to question of privacy. So I think it's something that is still unsolved at the global level. In Europe, we have kind of a treatment of data. In the US, they are very loose. And in China, probably the situation is even more difficult to tackle. So I think yes, they can introduce to bias into the interpretation. So it's up to the reader to see what these graphs are showing. So I mean, yes, the production is good, but you really need to do a double check and also be prepared to trash your tests if they are not working properly.
I'll
I
just,
would-
oh,
I
sorry.
was going to just add on that I think ethics is a really, really important thing that we need to be talking about a lot more. We're starting in the States to have conversations relative to a lot of other places about AI and regulations that are necessary for the safety and welfare of the public. I would say when we're developing tools, even something as simple as some of the examples I brought up today, a lot of us, what we're doing is persuasive communication in order to elicit a behavior or motivated change. We have a lot of conversations about what's ethical, how much persuasion is ethical, what does that mean, how we protect data, how we protect critical infrastructure asset information across the board. So there's a lot of conversation about this. I don't know if any of us have all of the answers yet because it's still emerging and these concerns are still emerging. At surface level, privacy is obviously something we're talking about, as well as the safety and welfare of the outcomes. But I will say, this idea of biased data from the data sets is not something new, right? It's always going to be related to the sample you have and the person who's analyzing the data, whether it's quantitative or qualitative. Qualitative tends to be heavier, but doesn't matter. Data and analysis has inherent bias to it. And so I think this is just another thing that we're going to have to address while we work through it.
During the AI summit, we had President Macron saying, plug, baby, plug, in response to President Trump saying, drill, baby, drill. So my question is about how much energy is required in order to, I would say, get, because we've got that increase of AI training and consumption. So then, you know, how much will be necessary in 5 years from now in terms of production, but in terms of distribution as well. I know that, for instance, in Netherlands, correct me if I'm right, you know, they are trying or they are limiting the expansion of data centers because it is creating some problems on the grid. So I think that there are some societal impacts as well as environmental impacts as well. And the final question is about, is it compatible with a CO2 roadmap towards net zero? It seems that there are lots of paradox, geopoliticals, impact, cost. I understand about the revenue and all the investors, how they are considering things in 5 years. You know, that's their typical also horizon. So if you could actually provide me with some guidance on that.
Well, I don't have the answer, but I would say that it's exactly the questions that everybody should be asking, and that is too often sidelined. And this is also the reason why the discussion about existential risks is also so important to reframe and not to leave in the hand of those who have interest in promoting AI no matter what, and you know, without asking why we should develop AI in the first place. Because when we start to think about you know, why would we want AI to do certain things, then we might think about our objectives is energy transition. So how we get to the energy transitions and how to, for instance, optimize the grid, and how maybe AI solutions might be interesting to optimize the grid. And then we can ask all those questions about cost, etc. And it's not the same thing than you know, starting from AI is there and how to make sure that we realize all those promises, you know, leaving aside all the questions about materiality that you're asking. But to do so, then it's important to start from you know, actual risks in the present, like those that the communities you're working with face, right? And it's completely different because, in a sense, they're facing existential risks, but they're not the existential risks as defined by the tech sector, who would say that, for instance, AI will replace the human race, right? It's a real risk now, and AI then could be relevant in the present to address that.
So one of the things, interestingly enough, about a week or two ago, I actually had some conversations with people who are focusing on just this in Texas, this data center issue, because of the immense water and energy footprint and the expansion and the speed of construction we need, as well as the supply chain. We have some issues of some tariffs and some steel that is changing some of the speed we can do it. So my disciplinary hat when I is in construction and implementation. So that's when that is what I am, if I were to say my civil engineering discipline is, that is what I did, that's what I used to do. So when I'm not doing these more community scale projects, I do a lot of construction. It's what I teach now. So I'm actually involved in some of those conversations, and we're just starting them, actually. I actually have reached out to a few people here because we're actually having a workshop just on this topic. How do we plan, identify, locate, build, bringing these data centers in location that have the least impact, and that makes sense. I will say it's different that we're not limiting data centers, to my knowledge, right now in the States, but how we get them in play to not impact the communities is something we're trying to figure out right now, and how do we build them at the speed they're needed is it's something that we're grappling with and having that conversation.
And Elena, you were also talking about smaller language models and frugal AI, right?
Yes, indeed. So there are quite a lot of, because I mean, this question comes every time in the research community, because we keep on having different model, bigger model, more parameters. Now we have hundreds of billions of parameters, and every time we want to do some retraining, all of these should be, you know, it's really, I mean, the energy consumption is really huge. So there are quite a lot of work starting in the last, I would say, year about creating smaller models, but with the same capability of bigger ones. We have actually just submitted a project on that. Because, so, actually, this can be coupled with another issue. So we keep on thinking about languages that are spoken by a lot of people. But what for low resource languages, for instance? So the idea is to try to have models, smaller models that can work for low resource languages, and then try to optimize also the bigger models and trying to see if we can actually obtain the same performances but with much smaller models. Or also developing new techniques to treat, to keep on fine-tuning, let's say, so to keep on doing detraining, but not from scratch every time. So trying, well, that's a bit more technical aspect, but trying to keep some parameters frozen, and every time we train just a small part. So there are a lot of works on the optimization of all these kind of methods to create something that is much smaller, that consumes much less energy than what we have today. But there is no real tangible results so far.
Maybe a quick question from the online audience, because we've taken some here in the hall. So what are the most effective day-to-day methodologies we can use right now to ensure that AI-enhanced knowledge systems produce credible, well-organized, context-relevant, and business-aligned content without sacrificing rigor or trust in the face of fast-changing information and internal or external environments? So mostly methodologies for having better data, better knowledge.
That's a very good question.
Use it for tasks you know the answer for.
Speed them up.
So I think we'll do another Powered by AI on this whole topic. Eve, if you want to maybe say a few words before we conclude.
Yeah, sure. So thank you again, all of you, for attending, both in the room and online. As you've seen, we've tried to not to be too deep in the technology or in the equipment for the energy system, but we wanted to tackle that from a different perspective, more on the communication aspect, trying to retrieve the information from the users, the consumers, the customers, the communities. We've also understood that it's really at every single level of the project, planning or development, a multi-stakeholder activity. So here again, when you have multi-stakeholders with different multidisciplinary specialties, we need to have collaboration tools. We need to communicate better internally in the company, within an ecosystem, and with the public more broadly. Of course, the different stakeholder in the sociology point of view are also important. Not only the technologists, the regulators, the technologists who may have a little bit too much to say today and to push for. So there is an equilibrium maybe to be found for the community, for the society, so that we're still, the humans are still in charge of where we want to, head. And a part of that should be kind of mission-driven with a purpose, have some of the panelists have mentioned. I would like also to bring to your attention that the ChatGPT has been mentioned only at the 52nd minute of the panel. Is that a kind of sunset of ChatGPT? So that's one of the first panels in a while where it didn't come as the second word. And I think that there are a lot of actionable aspects to be done for energy companies, and in particular ENGIE, with all the works that you've already started internally, with some of the projects that are exactly tackling those aspects: communication, visualization. Trying to feed that back within, some ways to display this information and to act and react to it. So I think that there will be quite a few recommendations to be made on that aspect. And again, thank you very much for your attendance. Thank you to the great panelists for the discussion, and to all of you. And here, I leave you the final word.
Sure, thanks so much. So we don't have answers to everything, but at least if we can ask ourselves the right questions, I think we'll have made good progress. So thank you, everyone. for being here. Those of you who want to contact us, please reach out to us offline if you have any questions or discussion items. The next couple of Powered by AI events will take place during VivaTech on the NG stand, the Agora. So please take those in your calendars. And also, if you want to sign up for future events, please flash the QR code here. Those of you who are here in La Défense with us, you're welcome to join us for a networking cocktail where we can continue to mingle and discuss these items that are very close to our hearts. And thank you for being here, and see you soon.